Okay. Hello, everyone. Thank you so much for being here. Today, we have the pleasure to welcome Karim Hamzaoui. Karim Hamzaoui is a specialist in business development and global partnership in Preferred Networks, top AI unicorn in Japan. Karim has more than 18 years career at the forefront of technology innovation, harnessing advancements in information technology to drive impactful value creation for customers and partners across industry. After graduating from Nagoya University, Karim began his journey at IBM, Japan's software R&D lab as a software engineer. His subsequent role on the lab strategy team sparked a deep passion for bringing technology and business. At Preferred Networks, he develops cutting-edge AI technologies ranging from in-house designed AI semiconductors to foundation models and AI applications. Karim has led transformative projects from R&D incubation to commercialization, spanning fields such as cancer diagnosis, autonomous driving, oil and gas plants automation, materials discovery, and generative AI foundation models. Additionally, Karim plays a key role in driving the company's global business initiatives and fostering international partnerships. Beyond his professional endeavors, Karim is a founding and current board member of the Moroccan Business Club in Japan. Kudos to you, Karim. This is very, very, very wonderful. An NPO, so this Moroccan Business Club in Japan is an NPO dedicated to strengthening economic and cultural ties between Morocco and Japan. So this is huge, Karim. This is very impressive, your career, and you are here. Thank you for being here, because this is the first time we have someone from Asia. So we used to have a lot of people from America, from Europe, and this is the first time we have someone from Asia. We want to have your perspective about what is going on in Japan. So today you will tell us more about navigating the AI technology stack. You will give us a global overview through the Japanese lens. So your talk will explore the AI technology stack from foundational infrastructure to cutting-edge real-world applications. This is in the core of the thematics of the theme of this year, so innovation through AI. You will examine how Japan is navigating the challenges and opportunities presented by the rapid advancement in AI technology. And throughout the presentation, you will highlight the few examples of innovation that illustrates how AI trends are being practically implemented in Japanese industry. So thank you so much, Karim, for being here. This is incredible that you have today, and the floor is yours.
Thank you very much, Professor Abdelhak. The pleasure is truly mine. I've been a big fan of the community MoroccoAI and what you have been done so far. Kudos to you, and the conference is amazing. I've seen all of them so far. So kudos to you, and I'm really proud that what the community has done, and it's a great pleasure and honor to be with you today. Thank you for the kind introduction, and it's a pleasure of mine to join. It's good to know that I'm the first one from Asia and from Japan. So I thought there are not that many of us, so I thought maybe I just bias my presentation a little bit to include more things about Japan and what we do here, and hopefully that could spark some discussion with the community. So thank you very much for the opportunity. I'm really looking forward to the conversation. So maybe I could share the screen then, and we could start it. All right, give me a second. Can you see my screen on my side?
Yes, go ahead.
Thank you very much. Thank you everyone for taking the time and be with us here today. I'm sure that you already have very thought-provoking presentations so far, and I hope this one would also shed a little bit of light on some perspective that might be of interest to you as well. So the title, it took me some time to think of what to share with you, but I thought since I'm on the other side of the globe from the country of the rising sun, I thought maybe I should talk about what's going on in Japan and from the perspective of the country and also from the perspective of our company as one of the players here in the industry. So it's a bit biased. It's a very tiny lens from which I see the current industry. So as Professor Abdelhaq shared, I have been in the industry for about 18 years, but when it comes to AI, most of the work or that I was involved in is in my current company was about 10 years. So I'm always on the job training. I've done computer science before, but for AI, it's all the work that we do here with our customers in Japan. So that would be the lens from which I will try to share in this talk. So let's start from Japan first. I picked a slogan that the leading party here in Japan, the government a few years ago, aspiring to be the world's most AI-friendly country. And what it means is that I think Japan is probably one of the unique countries that have a very direct and positive approach toward AI for a long time. Maybe because we do understand that we will have to include robots and these kind of technologies in our society for Japan to thrive. So I think there was a lot of excitement around the advancement that happened in AI in the last decade, I would say. And the way they do it here is that instead of having laws that are strict or forbidding this or that, they aspire to provide guidelines. So either how you would do R&D in AI, how to make AI, how to make humans in the center of the AI development, and also around the businesses. So they are trying to make it clear for the players here to know what is expected from them to do. And they try to do that by involving the maximum of stakeholders, either domestically here from the academia to the industry and the government as well, and also involving discussions with the international community. I just took a few shots here. We had visitors quite a bit to Japan to talk to the government and the industry, both from the closed source and the open source side. So it has been a quite an intensive dialogue around AI, the safety of AI, and what it could bring to Japan and the world. So it's a kind of very positive vibe, I would say. In the other side of thing, I think there's also, I would say, a sense of urgency where Japan, I think, as we are digitizing the businesses here or the industries in Japan, we've been using a lot of the technologies coming from outside, including things that are coming from the hyperscalers or I would say the social networks and things like that. So there is a kind of digital deficit that Japan is using more than it's producing when it comes to the digital services. And by seeing the growth that happened around Gen AI, there is this concern that maybe if this accelerates, we will probably be using more and more as AI becomes this base infrastructure of the economy. Then there is this urge to make sure that Japan is also contributing to that growth, and there is a lot of technology coming out of Japan rather than importing it and being a user. And there is also another positive side of things where as the semiconductor becoming very hot topic and very important industry to get right. In Japan, there is actually quite a nice ecosystem in the base that was developed when Japan was building its electronics and everything. So I just took a picture here that has a lot of logos around one semicon, and it's talking about all the companies that are contributing to making this silicon, from materials to the machinery. There are players that are leading the world or dominating in those domains. So Japan is trying to leverage those opportunities and be able to contribute to the revolution is happening around semiconductors for AI. So we talk a lot about AI, and I thought I brought the topic of the technology stack, and just to talk about the different innovations that are happening in all the layers. In the left graph here, I think this is from Andreessen Horowitz, the VC in the US, that are trying to figure out where the value will come from this stack. And you see in the dark blue, it's the infrastructure. So it's including semiconductors, data centers, cloud, and all those services. And then you go on top of that where you have the models, the chat GPTs and the other available models. And then on top of that, you build either an end-to-end application or you put applications on top. This is very simplified layers. And I think we already knew that the big winners will be in the infrastructure because they're providing all the tools that the industry is using. So NVIDIA has had a great run, including the hyperscalers as well. So in this talk, I'll try to go through each layer and probably share just a few examples of what's happening in those layers. And this will become the infrastructure of the economy. So it's something that's very important for the government and for the country as a whole. So sticking to that 3-layer model, I would say that the further down you go, the more expensive it is to play in that ground. For example, the semiconductor industry is a very capital-intensive industry, and here I think what the government has done in order to promote innovation is that it tried to subsidize or to help where maybe the governments can give the first push to get players more chance to contribute to these layers. So I would say that it becomes very capital heavy in the infrastructure side. The model side also as well, if you want to train large models, you need a lot of compute and data. So the government has been doing some programs to help companies to get access to GPUs. They're building national institutes as well. And when it comes to the application layer here, I think the focus is you're trying to figure out what are the big layers that you would want to move for the economy. What are the economies that are, or the industries that are important for the economy, where you can actually bring the most value. And here in Japan, it becomes healthcare, manufacturing, materials, and things like that. And also around the policies, I think there was also the debate around intellectual property. Here in Japan, I think it's a bit loose, so it's very easy to use data for training models. So they make sure that everything is clear for all the players so that it does not cause problems going forward. That's what's happening on the, I would say, the policy side, the government side. And this is the other lens where I look from, which is the company where I am, Preferred Networks. So we've been doing AI since the early age of deep learning, I would say, for more than 10 years right now. And we have been working across the stack. I think it's a bit rare for a deep tech company to go all the way down, and we design our own AI chips. Those are accelerators dedicated to do AI workload. And going all the stack, we build our foundation models, and then on top of that, we have some products that cater to the industry here in Japan. So I'll try to give examples from both sides. Starting from the AI chip. So this is the very bottom. If you go even further, you can talk about the energy and all the topics around energy. And I believe also Morocco would have quite a nice play to do there in the energy sector. But I'll just step on top of it, which is the AI processors. Here, the game is to have the highest efficiency you can get. So the wafer is the most expensive landscape in the world, and you want to make sure that you are using all that compute to its maximum, and you want to do that with the least consumed energy as possible. So that's the two KPIs you're trying to improve. And usually the chip here usually is you have the blue places where you are doing the actual computes, all the matrices that you're doing for AI, and then you have some controllers that decide which data to go where, and do that's kind of trafficking and decision. And this is actually consuming a bit of power and of compute from the wafer. So there is different approach to this where you move. This is an architecture that we've been developing with Kobe University for more than 6 years. And here we basically took all the judgment that is usually done on the hardware and we moved it to the software layer. So now we are leaving all the raw compute to be done on the hardware side, and then have the flexibility to do all the improvements and the optimization on the software layer. And we are now in the process of building the third generation. So this is a kind of every player, I think, is trying to bring a new approach to solving the workload of AI. So it's not only NVIDIA that will be supporting our economies in the future. And this actually worked quite well. This chip or this semicon, when we built the first supercomputer, actually we were able to be the #1, so the world most energy efficient supercomputer, 3 times in a row, not in a row, but 3 times in 2 years. So that was quite a nice achievement for a company like us. I forgot to mention that we are a startup. I think now we are about 300, maybe 330 people. But in order to compete in the landscape of semiconductors, we are collaborating with academia and also being quite nimble when it comes to providing this technology. That is for training. Then there is the exciting work that is happening around inference. I think everyone is, as we are developing these models and they're going to production, the workload is moving into inference type, which is a different type of problem when it comes to the compute. And you know that the memory bandwidth becomes the bottleneck when you're doing inference. And inference is also becoming more important, as you've seen in the recent models that are using like long inference, like the OpenAI O1 or other models as well, where you give time for the model to do inference for a long time to be able to think through the results, and it improves the quality quite a bit. And here, the memory, I'm just sharing like the 3 types that usually are used in the chip, from the DDRs you find in our gaming PCs to HBM used in NVIDIA, and then SRAM that has been used by some interesting players coming recently. The HBM gives you quite large memory, but it's a bit not close to the logic, so it's slower than what the SRAM gives you, while SRAM is a bit small. So I think you might have seen what Grok or Cerebras or companies that are doing some interesting work around inference, who are using these small SRAMs and trying to be as fast as possible when doing the inference. And there's building this massive infrastructure to do that. And I think in order to improve this even further, because SRAM is also not big enough for the large models that we want to do, I think there's this technology of doing 3D stacking RAM. So we are bringing the memory as close to the logic as possible, and that can give you quite high memory bandwidth also with the capacity as well. So I think that there's also like a lot of innovation happening here around semiconductors. Now we move a layer up. Now we talk here about foundation models, and I think there's no need to say that they are becoming important when it comes from the sovereign AI perspective, or just from building the application that you care about. And I think I need to start from the chart on the right, which is it's from the culture map book from Erin Mayer, where it compares the different cultures, how they make decisions, how they divide tasks. And you can see that every country or every culture has a different way of doing things. And since these models will be the base of our services and our system, we do want them to understand the business culture, understand the business customs, language, the law. So we do want them to have very deep understanding of the culture or of the system where we will be using them. I'll probably just pick on the Japanese way of doing decision. You can see that they are on the very far left here. So they do rely on consensual deciding, which is basically what we talked about in the policy. They involve all the stakeholders and they make sure that everyone is involved and decisions making not only from top down, but involving all the players in the economy. So I think there's different ways of doing things depending on the culture you're operating in. So that's like a background why we need these models to be catered to their economies. And in practice, this is just a very simple use case where this is a map of Tokyo, surrounding Tokyo Station. Here in the middle, there is the emperor is living here in the palace on the green. My office is actually just close here to the Otemasi station. And I'm comparing here the results if you ask a chat GPT or a model to give you some recommendation about French restaurants near Tokyo Station. For example, if you use ChatGPT, it will send you quite far, so it doesn't have that deep understanding of the location and things like that. While Plamo, which is the model that we developed for Japan, is a 100B LLM. It does understand that you are talking about this specific location, and it tries to get recommendations as close as possible. So this is just give you a very simple example of how it actually shows up when you're building services and applications based on these models. And from here, I'll go to the layer of applications, and I'll stay away from chatbots and language application. I'll try to focus on problem or on solutions that happen in the real world. So I'll start from robotics. Robotics is something that is important for Japan as we have an aging population, so we need to improve our GDP and our output using this automation. And usually the process in doing R&D, for example, I brought this example where we took this Toyota robot, we added all state-of-the-art object detection, understanding of the environment, and it was able to do autonomous tidy up. So it keeps picking up all the toys in the floor, cleaning up the room and everything. So technology-wise, you can do quite some interesting stuff. But when you want to bring it to market, then you have the limitation either of costs or it doesn't scale as well. Arm robots are quite expensive and difficult to productize. So here, what the team went for is that they look at what is the main function they want to support, something that is critical that they can support with the least cost possible. So they opted for this Roomba-like kind of thing where it goes and picks, so it attaches to different tables and it brings them to you. You might know that Japan is very small. Our houses are very tiny. So you don't want things to be around. So this kind of robot actually is making a difference in homes. And I think the voice is not here, but just to give an idea here. So it's talking to the robot directly and it understands what you want to bring to you and it will go and attach to the table and bring it to your place. You can also program it to bring you things in a specific time. So if you want to do exercise at 10 o'clock, it will bring you the table that has the weight and everything by 10 o'clock. And that kind of moving things around is a very basic function, but something that could be of use to customers. So this is just when you have restrictions in the real world, you're trying to find what is the most valuable thing that the customers are looking for and try to deliver that as cheaply within the constructs that you have. And by doing that, actually the biggest user that is, I'm not sure if my screen is still on. Maybe I should. think now it's full screen. I hope it's still on. Okay, yeah. So by building a robot that needs to cater for these very small spaces, it end up being very small, very cheap comparing to the usual AMRs that you find in factories and things like that. And we found that there are different type of users that were actually quite happy with this outside of the home, clinics, hospitals, restaurants, and things like that. So you can move from a very sophisticated R&D project to something that is simple and useful for a specific function, and then you can grow a platform out of that once you get it working. So this is like how you introduce AI into the real world. It does face quite a few obstacles usually. Another example here in the plant automation, which I'm involved with directly, and this is an example of automation for the crude oil processing unit. This is a very complex unit with more than 900 sensors that you need to monitor in real time, and you need to operate around 24 factors. And basically, the operators are well trained to make sure that the performance is stable at certain age. And then you can see that the AI is doing a better job. And usually in this kind of problems, it's never an pure AI driven data driven approach. It's usually you want to bring as much context or as much expertise from the operators, from the real world, and see how you can combine them with the model. It's usually what works in those setups. And this is the last topic. I'll move into science, and here it's around materials. I think I mentioned in the beginning that materials is very important for Japan in different industries, and there are many companies that are looking for new materials, either in batteries or polymers and things like that. And in manufacturing, a lot of the development now is moving to simulation, including automotive, aerospace. A lot of the development is done on the simulation, and I think material discovery also will do the same. It already started using some type of simulation, but I think it will go even in higher scales. And usually this is using like some very complicated equations to be able to calculate, let's say, the energy of the molecules and things like that. So it's very time consuming. That the simulation will take you quite some time in order to be able to verify. But I think with recent AI based models, I think it's becoming quite fast. And I'm bringing here an example that we worked on in our company. Here, usually, like you could always develop like a surrogate model to imitate some kind of function, and usually the problem there is how you can make it as general as possible. So you want it to be universal, and usually, if you want to do that, you need very large data set that can give you a lot of examples to generalize on, and that's exactly what we had to do. We used quite a lot of resources to build this data set, which is basically doing DFT, the quantum calculation to be able to create this synthetic data set. And then you train the model to be able to imitate what the DFT usually does, but you can do that now in a very, very fast manner, millions of times faster. And we were able to support a combination of 96. This means all the naturally occurring materials that you find in the world can be covered with this with combinations of these atoms. Now, when you have this, you can do what usually is done in drug discovery. You can scan across a large amount of materials, and then you can decide which ones are worth your time to actually make and test. And we've seen people doing simulation across industries. I mentioned batteries. There are, for example, people are looking for materials to do CO2 capture using MOFs, lubricants when it comes to the oil and gas. So there's a lot of, it's very universal, and I think the world is your oyster now. You can really look for interesting materials. And I thought probably I would close. There was some questions related to this in the registration form, I believe. Since now we know that the models are very smart. Some of them are PhD level. We've tested them in different areas and they're performing well. But can they do actually like science can do? Can they help us to invent new things, to create solutions to climate change and things like that? This is a question that is naturally raised, and I thought maybe it's worth to bring up as well. So this study was published, I think, from MIT a few weeks ago that took around 10,000 researchers, and they provide them an AI tool that generates material candidates for them, and they will decide which ones are worth it or not. And they had them use this tool and see how it improved their performance. So it took some time, a few months, before they got used to using the tool, but after a while, it did show improvement in discovering new material, increase in patent filings by quite a nice percentage. But the interesting part is that the bottom third actually did not improve their output. So the top researchers were very productive with these tools. They doubled their output while it didn't work for this. So there is this sweet spot where you want the AI to do part of the job, but you also want to include some expertise from the human side. You want to augment the whole process with AI, and so those are kind of combinations that are usually successful. So it did shift their work from doing ideation to evaluation. But it did cause a little bit of dissatisfaction because now they kind of felt that their work is maybe not that creative as before. But it also triggered some, I think, some motivation. And they mentioned that researchers were eager to learn how to be able to use this tool more productively. So this is the shifts of how you can do science by leveraging this tool. But I thought it's interesting that the large scale of researchers they tried with it is a good data point, I think, to think from. And then if you want to push this further, can it actually do science by itself? And this also has been tried in a few papers. The one on the right, the AI scientist, is actually from a startup here in Japan as well. And they went through the whole process from ideation to experimentation evaluation. Then you have the paper writing, and then you have a reviewer that actually do the review with you. Reviewer number one, reviewer number two for people who are submitting papers. So the interesting part is that they show that it does work, but the parts that was working the most or the best is the critical part, or the critic. So the reviewer was actually providing very nice feedback that improved the quality of the whole process. So sometimes the thing that is critical might be some components that you would not think it would be. But yeah, so I think this will improve further and further, including robots and automation. You probably can do this process as well in the real world, which I know there are many companies or labs that are doing this as well. So I think that the world is or the future is bright for this kind of approaches, I believe. So I think I came to the last slide of my talk, and just to close with some thought. It's definitely exciting times. I think there's no need to excite this community. We're all very excited with what AI can bring to our lives and to the world, and it will impact in all areas of our life. Every country has their unique way of approaching. So I mentioned Japan, how they have their unique and evolving formula. They keep updating the discussion as we go forward. They emphasize on innovation, but also helping with guidelines and things like that. One thing that is for sure is that no one has figured out the winning formula, or the one ring rule them all. So every country, every community, I think it's up to us to figure out our unique formula where we can use these tools to be able to create the future that would suit our ambition. So it's time for us to explore, to innovate, and thrive together. And yeah, so that's my final thoughts. One thing I'm sure is that this formula is definitely including MoroccoAI, and it's definitely a big player in that formula, and I'm really looking forward to what this community can build. Sorry, I think I went a bit over my time.
Yeah, thank you so much, Karim, for this very insightful talk. Really, it's very insightful. You make us dream about what is going on Japan, and you give us broad idea what is going on. Japan is focusing on the infrastructure side, not only the app side or the model development side, but the infrastructure is very important. And you at Preferred Networks, you focus mainly on the semiconductor part, because maybe the most of the value of the AI today is in this part. And you give us broad idea about the applications of AI, not only to do generative AI, but in science, in all the steps of science. How, if AI will replace the researcher? This is a very critical question. And yeah, you at Preferred Networks and in Japan, you apply AI in every aspect. And when we say that AI is applied everywhere, here we have seen that really AI is applied everywhere in science, in the inventing new materials, in biology, and so on. So maybe in Morocco, for example, we have an industry, or automotive industry, and maybe robotics, and applying AI in this industry, inventing new materials, for example. This will be something very important for us. And yeah, thank you so much for all these insights. I have a lot of questions. I will, yeah, a lot of questions. I will go through a few of them because we don't have much time. But yeah, I have this question. So I will come back to the question about the cultural and Japanese and Moroccan in Japan and so on. But here is a technical question. Developing surrogate models comes with a compromise between speed and accuracy. How do you deal with this in your company? This is a question from Radwan.
Thank you, Mr. Radwan. Yes, it does have. So usually, it is a compromise, or it is a trade-off. But I think you can keep improving the accuracy as you are increasing the data. So you do that in a type of active learning kind of approach, or so you build first on the data you have, and then you test where it's not enough, and then you keep increasing. It's a very iterative process. I showed the material table, and I should say that in the early versions, we were not supporting 90 materials. We were supporting a subset of that, and then we keep increasing as we are confident about the accuracy that is produced by those surrogate models. So I think it's an iterative process, but even in the case of DFT, since it's also a mathematical equation, it is also different from what happens in the experiment. So sometimes the models are even better than what you were trying to imitate. So it does become interesting where you are. When you keep improving, you do reach a saturation where you kind of find a decent compromise that is worth it. And you can use if you have like a low accuracy model, you can do the first scan, and then you can narrow and maybe make the model larger to do more expensive calculations. So you can divide that into steps as well. I hope it answers.
And yeah, you share the broad idea of what is going on in Japan. Here in Morocco, we have this question of how to get this AI working in many industries, and we are faced with this question of computational resources. How is Japan dealing with this challenge of computational resources? If there are private clouds or public clouds, or how Japan is dealing with that?
So you mean the computational, meaning when you want to deploy them in your
training and deploying model.
Training and Yeah, so I think in training is what I mentioned around trying to build this compute. We do have the hyperscalers, the GCP and the AWS, so we do have the cloud. But in the same time, I think large companies, they do have their on-premise infrastructure. Institutes in Japan, like research institutes, they might have their supercomputer infrastructure, things like that. But on the deployment side, I think is where the challenge usually happens. When you're doing things in like an IoT kind of setup, or where you have like very small chips that you can not run large models. I think that's what usually it would take time for or it took time for deep learning to reach those kind of deployments, and it will take time for Gen AI to reach there. But there is quite nice work around like small language models, the SLMs, where you are trying to make smaller ones, but specific for the function you want. And we have started to do that as well. And you can get surprised with the quality that you can get from a very small model if you really narrow down the use case. I think that would be the first way of how you can bring this Gen AI to the on-device kind of deployment.
Yeah. And the question is very related to the availability of data, right? Because in Japan, you mentioned that there is a lot of work about having data in hand to train these models. Especially Japan is, for example, for text or generative AI or LLMs, Japan language is different. Maybe most of models we are seeing today are trained with language models like English. What is the specificity of Japan in this case?
I think we also started from the same starting point, starting from the internet. But what happened is that there is a lot of documentation, for example, in the, how do you call it, the government library or the parliament library, or so there is some document that have higher quality of what you find in the web. So there were some active work into trying to make that data available, because it's the data itself is open to public, but it's usually in very bad formatting. It's in some weird PDF, sometimes some weird systems that you need to go and log in. So there was some work to trying to gather that text data into a format that can be used by to train these models. I think it was in one of the institutions. So within the research centers, I think they collaborated with some institutions to be the consolidator of the data for text, and they talked to another institute to collect non-text data, meaning images or other. So I think there was some help also from the government to be able to at least have the baseline, or to have some data where people can start building, and then every company will have their competitive data isolated. But having high quality text was quite interesting, or was quite important, I think, to get to the quality that we wanted.
Okay.
And I would guess that, or I would probably in Morocco, that is one of the things where we need to figure out how to all this know-how that we have, or the culture, or the expertise that we have, is probably not documented in books or in documents. So for us, how to bring this to data so that we don't disappear from history, because maybe in the future people will not be looking into books, they will be probably looking into the weights of these models. So we need our inputs to bring it out there, to be available for these models to learn from and to contribute to those models. Sorry for my long answers. I think I should to be shorter later.
Yeah. There is this question. I will read it. So, how do you ensure a balance between innovation and ethics? Which model is close to you or to Japan? Europe is more ethics, and US is more innovation, freedom of innovate. So, what's your thought about that?
Yeah, I think Japan was quite not. it was the country advocating for being cautious, but not locking things down. So I think it's not the Wild West as in the US, and it's not very strict as in Europe. So they were promoting this, let's get together, try to figure out the risk, let's make some guidelines, and that was their approach. So I think that's why a lot of the companies are, they were looking into building or to building like research centers here in Japan, just because it's friendlier to AI. So that's the kind of stance that at least that Japan is taking for now.
Okay, so maybe I will ask you last question because I have 10 other questions in the...
Yeah, please, you could reach out to me like either on
Yeah,
social networks or
exactly.
anything. If you want to communicate later on, I'd love to.
I will send them to you. And my last question is about the Japanese, the Moroccans in Japan, how they are doing there. And I will love to connect, MoroccoAI will love to connect with folks and Moroccans residents in Japan, doing AI or science in general, because we lack some connections there. So how your community is doing in Japan?
So the community in Japan is not as large as in I would say in Europe, or forgot the number, but I think it was a few thousand or something like that. So it's a bit tiny, but a lot of us, or many of us came into this through the education program. So we did other studies. So we have this network where we either like get connected through that scholarship program or things like that. Yeah, but there are people working in all domains, so it would be interesting to see how we could connect. It's usually difficult for us to keep having a good pulse on what's going on in Morocco, and I'm really happy for this occasion, so that we have this this dialogue, and maybe we should increase more of these discussions.
Yeah, they are most of welcome. You are most of welcome to MoroccoAI and to connect with the MoroccoAI community here. And we would love to hear about you and the community. And let's connect here in Morocco when you come to Morocco.
It's a pleasure, inshallah. Definitely.
Thank you so much, Karim. And
thank you very much, and kudos to you. I know that it takes a village to make this kind of conference, and you do have a very strong village in this community. Thank you very much for what you're doing for Morocco and AI. It's very exciting. Thank you very much for having me. Right, so
the webinar.